Friends, welcome back to a new session. In this video, we are talking about integration of trigonometric function by successive reduction. So we know what is integral of sin x dx, which is equal to minus cos x dx plus c. So here we get this answer from derivative, which is the opposite of integration, or vice versa. So first we know that d by dx of cos x, which is equal to minus sin x. So from here we can easily find what is the integral of sin x, which is equal to minus cos x, by using the integral which is the opposite of derivation. So in this video, we are mainly talking about not to find integral of sin x dx. We want to find that what is integral of sin nx dx. So here, which making the n, the power of the sin, which is the nth power, which making the situation as complex one. So let's find how to find a solution for this integral sin nx dx. So before starting this session, don't forget to subscribe our channel due to the more videos based on this session which will be coming soon. So first we want to find how to find the solution for in is equal to integral of sin nx dx. So here we taken as this sin nx dx as in, due to I means that integration and n means that the nth power of the sine function. So here we want to find as put in is equal to integral of sin n minus 1 x into sin x dx. So when solving this one, we get as the previous one. So if you any doubt, so please check it out. Then this next step, we want to find that by using a principle, that is integration by parts. Integration by parts. By using the integration by parts, we know the main equation of integration by parts, which imply that the first function into the integral of the second function minus the integral of derivative of first function into integral of second function whole dx, like one. Then we want to find that what is in. Then here we taking as sin n minus 1 x as first function and sin x as second one. Then put it as in this formula. Then we get as put first function as sin n minus 1 x here. Then in second, integral of second dx. Integral of second means that is integral of sin x dx. Integral of sin x dx minus whole integral of d by dx of first, that is the derivative of the first function, d by dx of sin n minus 1 x dx. N minus 1 x dx, sorry, only d by dx sin n minus 1 x, not dx. Dx is also mean that in the case of integration we want to find this derivative. Then in second, integral of second dx, that is integral of second means this same one, that is integral of sin x dx, then whole dx. Then solve this as properly, we get sin n is equal to sin n minus 1 x integral of sin x dx. We know what is integral of sin x dx, which is previously we said that integral sin x dx, which is equal to minus cos x dx plus c. So note that we want to only write minus cos x here, so not is dx here, minus cos x, due to here this c, which implies that which is an indefinite integral, so it is not definite. We want to put in the outcome as plus c here. So likewise we want to not put here as plus c, due to finally in the final answer we want to put a at last we want to put a plus c in the whole equation. So first you don't consider the c here, then minus cos x put here, minus cos x, then minus integral of d by dx of sin n minus 1 x, which is equal to, by using the formula for d by dx of x raised to n, which is equal to n into x raised to n minus 1 here. Then using this formula we can find the derivative of sin n minus 1 x dx. So simply we can find the answer as n minus 1 into sin of n minus 2 x Likewise, then integral of sin x dx, which is equal to this one. Then minus cos x. Oh, sorry, there is one more thing, that is we put first find as n minus 1 into sin n minus 2x here. Then we want to find the derivative of sin x also by due to the reason of chain rule. So don't forget that the chain rule is important thing. So first we find that n minus, that here n into x raised to n minus 1 into 1 is existing. Likewise here n minus 1 into sin n minus 2x, which into this derivative of sin x again, which is equal to what is d by dx of sin x. D by dx of sin x equal to cos x. So put it as here cos x. Then finally in bracket and dx here. Then in, which is equal to sin n minus 1, this minus sign here, then cos x here, then minus, there are two minus here, then minus minus, which is equal to plus, and take n minus 1 in the out of the integral. Then integral of sin n minus 2 x into cos x, which is equal to cos square x, and dx, which is equal to minus sin n minus 1 x cos x plus n minus 1 integral of sin n minus 2 cos square x. Here cos square x, by using one principle, that is cos square x plus sin square x, which is equal to what? 1. Then we can find what is here cos square x is equal to cos square x is, which is equal to 1 minus sin square x. Likewise, this equation we put as here, that is the case of cos square x in case. Then integral of, first put sin n minus 2x here, then cos square x is replaced as 1 minus sin square x, then 1 minus sin square x dx. Then in, which is equal to minus sin n minus 1 x cos x plus n minus 1 into sin n minus 2x into 1, which is equal to what? Sin n minus 2x. That is integral of sin n minus 2x dx. That is sin n minus 2x dx, which is multiplied inside the bracket, and we get as first term as here sin n minus 2x dx, and minus sin n minus 2x into sin square x, which imply that what? Sin nx dx. After we want to write as sin n minus 1 x cos x, there is not change in these term as in each step. So in the next case, n minus 1 into sin n minus 2x dx minus sin n x dx. So we want to write this term as in minus 2, that is integral of sin x dx and integral of sin n x dx, that is put as separate integral here. Then we can write the sin n minus 2x dx as in minus 2, that is, which mean that integration of n minus 2th term, that is the power is n minus 2. As previously we write the sin in means that what? The integration, and n means that is the nth power of the, sine function. So likewise we can return like it as this, due to sin n minus 2, the integration of the sine function with n minus 2th power, then put a minus term, then the sin nx dx, which is equal to what? In. Then put a bracket in. Then in this next step we want to do that n minus 1 as multiplied or opening this bracket, then n minus 1 into in minus 2 and n minus 1 into in. Then n minus 1 into in, that is minus of n minus 1 into in term, which would be taken to the left hand side from the right hand side. Then we get another result as in. Then minus sin n minus 1 x cos x plus n minus 1 in minus 2 minus n minus 1 in. This step we want to do that here n minus 1, this term, to take it as in left hand side, then which means that n, that plus n minus 1 into in, which is equal to this term, then which can be written as minus sin n minus 1 x cos x plus n minus 1 into in minus 2. By here we can write it as in, here open this bracket, we get as in, which plus nin minus in, which is equal to minus sin n minus 1 x cos x plus n minus 1 in minus 2. So here we don't open the bracket, that there is a reason behind this. To simplify the equation, we get a proper answer, and here only this one we are open this bracket only, then cut is in as term, then we can finally get nin, which is equal to minus sin n minus 1 x cos x plus n minus 1 in minus 2 term here. Then in this next step, we want to find that in, that is in which is equal to that is divide this term n as by this equation, then divide this whole term by n, then we get as minus sin n minus 1 x cos x all divided by n plus n minus 1 divided by n in minus 2. This is the final result, that for the finding the value for in. Then finally we can get an answer, like as here we written it as integral of sin nx dx, which is equal to minus sin n minus 1 x cos x all divided by n plus n minus 1 divided by n integral of sin n minus 2 x dx here. So note that we derived here as in, which is equal to minus sin n minus 1 x cos x divided by n plus n minus 1 divided by n into in minus 2. So we replaced finally in as integral of sin nx dx, and in minus 2 as integral of sin to the power n minus 2x dx. Likewise, we get as a final answer as here sin nx dx, which is equal to minus sin n minus 2x cos x divided by n plus n minus 1 n integral of sin n minus 2x dx. So this is the solution for integral of sin nx dx or in. Now we get an equation integral sin x dx. So now there is another question, that how to find its integration by using this formula. So let's find the solution for integral of sin raised to 4x dx. We want to find here integral of what? Sin raised to 4x dx. That is this one. So this is which is equal to minus sin raised to n minus 1, that is 4 minus 1, which is equal to 3x into cos x all divided by n, which is equal to 4 plus n minus 1. N minus 1 means 3 divided by 4 integral of sin n minus 2x dx, which is equal to sin square x dx. So here we want to put the equation as once more, due to here arising integral of sin square x dx, which is in the form of integral of sin raised to nx dx. Then the next situation, integral of sin 4x dx. So I raised to 4, which is equal to minus sin cube x cos x divided by 4 plus 3 by 4 into sin square x dx, which is equal to what? Put a bracket, then we can write it as minus sin n minus 1, that is sin x into cos x whole divided by 2 plus right here and then here n minus 1 divided by n, which means that 2 minus 1 divided by 2, which is equal to 1 by 2 into sin n minus 2x dx, which is equal to what? Into integral of sin n minus 2x dx, which is equal to sin, here 2 is the n value, then 2 minus 2, which is equal to 0, that is integral of sin 0x dx, which is equal to 1. So integral of sin 0x dx. Then solve this equation, that is I4, which is equal to minus sin cube x cos x divided by 4 plus 3 by 4 into minus sin x into cos x divided by 2 plus 1 by 2. Then multiply by this bracket by opening this bracket, then multiplied with a 3 by 4. Then we get minus sine cube x cos x divided by 4 plus minus 3 sine x cos x divided by 4 into 2 which is equal to 8 plus 3 divided by 4, which is the final answer for this equation. So note that here the final answer is I4, which is equal to minus sine cube x cos x divided by 4 minus 3 sin x cos x divided by 8 plus 3 by 8, not 3 by 4. I mistakenly written it as 3 by 4. That is 3 by 4 into 1 by 2, which is equal to 3 by 8, not 3 by 4. So please check that and note that the mistake. So thank you for watching this video. In this next video, we want to find the solution of the integral of cos nx dx, which is the same as the formula as used in the previous the solution to or derivation as find for the sine function, as same as in the cos function. Only change the function here, the nth power as same, and these small changes in equation as occurring in this derivation. So in this next video which will be soon to with more information about this function. So don't forget to subscribe our channel for more information. So let's see in this next video. Bye bye.